No.
Okay, guys.
You're looking both.
Lesson 4.8. What was up on the screen at the beginning is what we did back on a week ago in notes, right? I put it up here. Those of you that missed it, I saw some of you copying it down. Awesome. But also, did you go through and try and remember what we were doing? Because I know it's been a week ago. And now I'm going to ask you to finish the lesson and do the homework over it. So, remember, the idea is normally up until this lesson, when I say, okay, what's the square root of a negative number? You'd be, oh, my calculator tells me it's an error, or I can't do that, or, you know, whatever your response was, right? Well, now, that's whenever we're working the real number system. Now we're talking about imaginary numbers, and we have the square root of a negative number. Remember, I was just kind of pulling out the square root of negative 1 as a separate number, and that square root of negative 1 is I. And so we were able to work with these square roots of negatives. The other thing to remember up here, so square root of negative 1 is I. And then what happens when you square I? This will be important to know when we get to the back of our notes. When you square I, you get negative 1. Okay, so we're not to needing that point yet, but we will need that. Those will be the two pieces of information to need. Okay, so this sounds a little familiar, right? We also, like if you go back to the square root of negative 18, there was a negative 1. You also remember looking for perfect squares last week? If I do square root of 18 on my calculator, I can't do it, right? It's a decimal. But what's a factor of 18 is 9. And 9 is important because we can take the square root of 9. And so that's why here on this first one, square root of negative 1 is I. The square root of 9 is 3. So 3i out front. And then the square root of 2 over there. Over by where Max is. Or I didn't even think about that, but there's a power strip right by McKaylee.
Oh, okay.
But yeah.
Who is Max?
Mac, McKaylee.
Oh, I said Max, like with an X. I'm like, oh,
Okay,
there's a
moving
Max
along.
here.
Okay, down at the bottom of that front page. First of all, complex number. Okay, so when we talk about these imaginary numbers, these i's, okay, a complex number is written in the form a plus bi. Okay, so we'll often see this a plus bi part, where a is the real part. So notice a is just a regular old number, and then bi is the imaginary part, because b is multiplied by I, so that is the imaginary part. Just like the coordinate plane. So when we talk about graphing, right, with x and y axis, just like the coordinate plane, there is a complex plane where the complex numbers a plus bi are graphed. And that's what we're going to do down here. Good news is it's very easy graphing. If you can graph an ordered pair, you can graph a complex number. Okay? So, a plus bi, so right here, folks, a plus bi refers to the ordered pair a comma b. So the real part, a, is kind of like your x. The number that's with the imaginary part, so the b, we don't use the I part, but the b that is attached to the I, that is like your y value. And so we come down here, we're going to work on graphing like negative 5 plus 3i. And then the other thing we're going to work on doing besides graphing is we're going to talk about how to find the absolute value of a complex number. And you'll notice, so absolute value of a complex number. First of all, absolute value. Remember, we're asked to find absolute value by looking, they put it in those straight bars. Not parentheses, not brackets, it's just those straight bars. Huh? They put it in prison, is that what it is? Okay, well. Anyways, in order to do the absolute value of a complex number, we can't just make it positive. It's a little more complicated than that, but they give us a formula here. So anytime you're asked to find the absolute value of a complex number, you're going to be doing the square root of a squared plus b squared. Okay? And of course, remember, absolute value is the distance from 0, so that's going to be the distance that ordered pair is from the center, from 0, 0. Okay? So let's look at example 2 here. They ask us to graph it and find the absolute value of the number. So if we look at -5 plus 3i, remember this is of the form a plus bi. And if an ordered pair is a comma b, what is the ordered pair I'm graphing here? Okay, I'm going to be graphing the ordered pair, -5, comma 3. Where -5 is the a, 3 is the b, so -5, comma 3. So if we go over here and graph this, which we're just going to graph these all on one grid right here. First of all, instead of thinking x-axis and y-axis, we're going to think about these as the a-axis and the b-axis, or if you prefer, the real axis and the imaginary axis. Okay? So -5 plus 3i. How do we graph the ordered pair -5, comma 3? First number tells you left or right. Second number tells you up or down. This takes us back to like elementary, middle school math, right? So if I go left 5, 1, 2, 3, 4, 5, up 3, 1, 2, 3. So that point right there represents, I'm just going to write it in here, -5 plus 3i. Can we handle that kind of graphing there? Okay. Before we move on to the next one, we also want to talk, that's the graph, we also want to talk about absolute value. So absolute value of -5 plus 3i, remember there was a formula, yes? Absolute value of a squared, square root of a squared plus b squared. So I'm going to be doing the square root of, what's my a value? -5. So I'm going to say -5 squared plus, what's my b value?
Would we just put 3 squared?
Just 3, yep.
So we don't put the I in there?
No, because it says the square root of a squared plus b squared. It doesn't say the square root of a squared plus bi squared. It says the square root of b, or it involves a b. So if they want it to have an I, they tag the I in there. Okay, do the math here. What is -5 squared?
25.
25. 3 squared?
9.
And 25 plus 9?
34.
34. What is the square root of 34?
Square root of 34.
Okay, depending on the scenario, and in this case, I am going to say, just like that, square root of 34. The other option might be to say that it is 5 point whatever, which, you know, that's a calculator type problem there. But for, I know in my notes I have square root of 34. I'm pretty sure Math Excel is going to say square root of 34 as well. Okay, and I can't remember if you have these in the same type problem or different problems.
On a test, will it say which form we should put it in, like a decimal or the square root form?
On a test, my thought is always, okay, what did we do in notes? What did you do on the review worksheet? And usually it would say, or I'd be able to tell you. Okay. Okay. Other questions on A here? Okay. What are your thoughts about B?
The A value is 0.
0.6.
Okay, so if I rewrite this, if you're sitting there saying, I don't know, it's 6i, Mrs. Sargent, that's not in the A plus BI form. Think about it this way. 0 plus 6i. Is 0 plus 6i the same as saying 6i?
Yeah.
And now it's in that form of A plus BI, isn't it? Obviously 6 is our B value because that's the imaginary one. The real value is the imaginary 0. So this ordered pair you can think of is 0, 6. How do we graph 0, 6?
You go up 6.
Okay, left or right 0, up 6. And so that I'm going to say is 6i. Okay. Absolute value. Kylie?
6.
Did you do the math on that?
Yeah.
Okay.
Basically.
Would it just be 0 squared plus 6 squared?
Squared, which is the
That's
square root of 36,
and
and then
Okay.
square root of 36
Now.
is 6.
If I wanted to say you guys could do this one without using that formula for absolute value, would you believe me?
Yeah.
Yeah.
Because what is our definition of absolute value? Distance from 0. How far is this point 6i from the origin 0, 0?
6.
It's 6 up, isn't it? Okay. Now, the math to prove it. If I do my square root of a squared plus b squared, so that's the square root of 0 squared plus 6 squared. Well, 0 squared
0.
is 0. 6 squared is
36.
36. And 0 plus 36 is 36. Now, when I say square root of 36, should you leave it as square root of 36?
No.
No way, no how.
Square root of
It's going to become not square root of 6,
6.
just 6. Okay? And if you want to argue me and say, Mrs. Sargent, I didn't show a bit of work there. I get it. Because I can just count that is 6 boxes up from the origin. As opposed to this one over here, negative 5 plus 3i, that's on a diagonal, isn't it? Because it's on a diagonal, I can't just say, oh, yep, it's this many units from 0, 0. Okay. C. Did you already do C?
No.
Yeah.
Five minus I. How do I graph 5 minus I?
5 negative 1.
So if we think about this as A plus BI, A is 5. What is my invisible number there in front of I?
Negative.
There is a 1 there, so negative 1. Five negative 1 tells me to go right 5, down 1. To get absolute value from this one, do you have to use the formula? Yeah, you're going to have to use the formula on this one because we're going at a diagonal. So, right there, folks, absolute value, yes? When you see absolute value in homework, go back to your notes and say, oh yeah, it's that formula. Square root of A squared, what's A? 5 squared plus, what's B?
Minus 1 squared.
Negative 1 squared. So 5 squared is 25. Be very careful when you guys go to do this on your own later. What happens when you square negative 1?
Plus 1.
It becomes positive 1. If your calculator tells you it's still negative 1, that's because you didn't use parentheses around it. Okay? So you have to use those parentheses on your calculator, or just know it's going to be a positive 1. 25 plus 1 is 26. What is the square root of 26? Okay. It is some decimal. It is 5 point something. So I'm going to leave it as the square root of 26. Okay. Yeah, go ahead. Do we need to do, I don't know. Do I need to do this one?
Why
Not really, but let's.
Sure, why not? Let's do it.
What point did you graph? -3, -2?
Yes.
Where does a -3, -2 take me?
You go to the left 3 and down.
Left 3 down 2. Please be practicing with me, right?
You go to quadrant 3.
Okay. And then, what is the absolute value of this? Did you do the math?
-3 squared.
Okay.
Squared.
So square root of a squared plus b squared, so square root of -3 squared plus -2 squared. -3 squared is 9, -2 squared is 9 plus 4.
13.
And what's the square root of 13?
The square root of 13.
3 point something.
One type of definition.
Okay. Okay, we can handle some of that basic stuff when you go to start homework tonight. Okay. Let's move on to the next page then. Example 3, top of the next page. Notice it says adding and subtracting complex numbers. So now, when we talk complex numbers, remember when we talk complex numbers, we're talking about numbers that are in the form a plus bi. So I'm adding and subtracting numbers that are in the form a plus bi. Now, it's a silly question for me to ask, but I have my reasonings, okay? It'll make more sense later. How do I know that these are addition and subtraction problems?
The sign. So,
Okay, notice what's in between the parentheses on this first problem.
that's addition.
It's an addition sign, yes? It is important to notice that, hey, there's an addition sign right there. So I know that this first problem is adding. We're being asked to add 4 minus 3i and -4 plus 3i. Any guesses? Thoughts on how we might add these two numbers? Say it again, Justin.
I said you add your 4s together and then you add your 3 i's.
And why would you say that?
Because they're the same. They're technically the same.
The same. What's a good?
Like,
What?
Like terms.
Okay, like terms. Okay, is this a lot like when we add with variables?
Yeah.
Okay, I is not a variable. I is the square root of -1. However, when we go to add and subtract, okay, yes, think add like terms. Officially, what do I'm going to tell you. I'm going to say add your real part with your real part, add your imaginary part with your imaginary part. Yes. So what do we have in the way of real parts?
4 -4.
So we're going to be adding 4 plus -4 in our real parts. And what do you know about 4 plus -4?
They
They equal 0. And then
have -3.
we have our imaginary parts. My imaginary parts are
Also equals
-3i and
3i.
positive 3i. What is -3i plus 3i?
0.
A 0. And then officially, what type of problem was this?
In addition.
It was an addition. So all I have to say, 0 plus 0 is going to give me
0.
0. Okay? As I think it was Hunter that said, they canceled out, didn't they?
Yes.
The real parts canceled, the imaginary parts canceled. They had to be 0. Now, I wasn't in Math Excel this morning, so I don't remember because this would have been done, over a week ago on my behalf. I am perfectly fine with the answer of 0. Trying to think, will Math Excel ask you to put it? I don't have it in my notes, so just FYI, if Math Excel wants you to put that in complex form, that's 0 plus 0i. Okay? So I am perfectly fine with 0, and I think I don't have any notes here in my notes, so I think that it would just be as is there. Okay? Okay, let's try B. What do you notice about B?
Subtract.
Okay. So first of all, we have to pay attention to the fact that this is a subtraction problem. So if we start thinking about the real parts, what's going to happen when I subtract my real parts? Do you understand what I'm asking there? So the A values.
5 minus negative 2.
Okay, so this is going to be 5 minus negative 2. And what do we know about 5 minus negative 2?
Positive 7.
Okay. Positive 7. If you want, it's keep, change, opposite. 5 plus positive 2. Okay. Real with real. Now what? Not fake. Imaginary part. What are my imaginary pieces here? We have what kind of 3i? A negative 3i. What are we doing with these pieces? We are subtracting. And what are we subtracting from that negative 3i? A positive 4i. Are you catching what I did there? You have to watch that subtraction. What is negative 3i minus 4i?
7i.
Minus 7i, negative 7i. So here's what I'm going to say. You just told me that imaginary part, that 7i is negative, yes? So I'm going to write my answer as 7 minus 7i. If I had found that they added to be a positive 7i, then I'd say 7 plus 7i. But I'm putting that negative in there because this part was negative 7i. Are you guys okay with how I did that? Okay. The other way, and I debate, the other way I could see this taught. You know, you go to another teacher might teach a different way, is some people would teach to distribute the negative sign. And if you distribute the negative sign, you would have had the 5 minus 3i minus negative 2i, which minus negative 2i becomes plus 2i. Or not, it's not an I, is it? It's just a 2, sorry. Minus negative 2 becomes plus 2. And then minus a positive 4i is minus 4i. If you would rather write it out like that first, and then put like terms together, you could do that as well. Okay? Either way, we land at the answer of 7 minus 7i. And that's where I need you guys to end up. Okay, C. What do you notice about C?
There's 3 of them. Both of them.
Okay, there's 3 of them.
There's both circles.
There's adding here, and there is subtraction there. Now, you could go through and rewrite the whole thing without parentheses, which just means changing your signs after your minus sign. Or go through and grab the real parts, go through and grab your imaginary parts. Again, I don't have this is the right way, this is the wrong way, because that's not the way it is. There's multiple ways you can do this. What do you see happening with reals? Let's start there.
Oh, you got stuff.
Okay, so I have a 7. I'm going to say plus a negative 3, and then we're going to say minus 3. Are you guys okay with what I did there? So I had a 7. We grabbed the plus sign from the middle. Then it was a negative 3 real part. Then we grabbed the minus sign, and then it was a 3 real part. So 7 plus negative 3 is 4, minus another 3 is 1. Similar thing with the imaginary pieces. What do you have in the way of imaginary pieces? First one is a negative 2i.
And then another.
I'm going to say plus, and this time I'm grabbing an I. And this time I'm going to say minus, and what are we subtracting?
2i.
Not 2i, but negative 2i. What do we know about minus a negative, though?
It's a positive.
It's really plus positive. So negative 2i plus I plus 2i. 1i. I look at negative 2i plus 2i cancel each other out, and so we have an I. Since that's positive, I'm going to say plus I. If you did it differently than me, the key is going to be, did you get the same answer as me? Okay? Maybe you did it along the way differently. Maybe you did things in a different order. As long as you end up with the same answer, we're all good. Questions there? Yes?
Does it have to be in that exact order?
Usually, when you express answers that have a complex number that has a real and imaginary part, you usually put the real part first and then the imaginary part. Will Math Excel let you put I plus 1? I have no clue. You can tell me tomorrow,
Okay.
because I really don't know. I don't remember how flexible Math Excel is with this. So, I mean, it's equivalent. I'm not going to argue that. Okay, have you started looking at example 3 yet? What do you notice about this next row?
You're multiplying.
Okay. Well, first of all, the directions say we are multiplying complex numbers. What do you notice with the parentheses? They're what? They're together, right? There's no plus or minus sign in between them. I point this out. I know it sounds crazy because your guys like, it's obvious. Here's the deal. Multiple someones are going to mess this up on the homework, and they're going to mess this up on the test. Okay? So I warn you to be very careful. Watch. Up above, there are pluses or minuses in between the parentheses, right? That's add and subtract like terms. Down here, they're together. There's no pluses or minuses in between them. So we are multiplying. Okay? So we're multiplying these complex numbers. Thoughts on A, because we've got several different things happening here. Thoughts on A of how to multiply 3i times negative 5 plus 2i. I wouldn't put a 0 in unnecessarily. Right
I'd
here.
say a 1, right? What a 1 word?
Then you just have to 5.
Just think if those were x's instead of i's.
Then you just
Or
take,
distribute.
you just take 3
The
out.
opposite, right? So just think of this as if those were variables, okay? If those were x's, you would take the 3x and you would distribute it and multiply it by both pieces, right?
Yeah.
So this is a 3i. We're going to distribute. So what is 3i times negative 15 times negative 5?
Negative 59.
Okay. 3i times negative 15, so 3 times... Oh, my goodness. Read my mind. Obviously, I am jumping ahead to the answer. 3 times negative 5
Negative.
is negative 15, tag an I on, plus 3i times 2i.
Dewey squared. Negative 6i squared.
3 times 2 is 6. I times I is
Squared.
I squared. Just like variables. If you multiply x times x, you get x squared. So we're multiplying I times I, we get
I squared.
I squared. You treat them a lot like variables.
I'm squared.
Now, however, with variables, they're not like terms. We can't go any farther. We would stop here.
But once your I squared, you negative 1.
Okay. I specifically pointed out on the previous page, I said, it doesn't really matter right now, but later on you need to remember that I squared equals negative 1. You will never have a final answer that involves I squared.
So would it just be plus 6 times negative 1?
Yeah, well, so what we have to look at here is that this I squared is equivalent to negative 1. Okay, so we still have the negative 15i plus, and since it was 6i squared, that is 6 times negative 1. What is 6 times negative 1?
Negative 6.
Negative 6. So now I'm going to rewrite this as still negative 15i, but I'm going to say minus 6. Now, again, I wish I would have thought to check, but My Monday morning after 5 days off brain was not thinking like that. Okay. Will Math Excel let you leave it like that? Or do you have to put it in A plus BI form? I know it's nitpicky, but why is this not in A plus BI form?
Negative 6 minus 59.
Yeah.
Yeah. A plus BI form is going to have the real part first. So if I flip this and put the real part first, it's negative 6 and then minus 15i. Again, would Math Excel maybe let you put negative 15i minus 6? Maybe. Okay. Will Math Excel let you leave it negative 15i plus 6i squared?
No.
No, and neither will your teacher either. Okay. So negative 6 minus 15i is getting it in that form. We have the real part, then the imaginary part. Okay. The trick to learn here, folks, when you see an I squared, basically what happened, we dropped the I squared off and changed the sign on the 6. It went from a plus 6i squared to a minus 6. But the reasoning is because I squared is equal to negative 1. Okay. Questions there? And I will say, the directions will probably say to express your answers in complex form or A plus BI form. So there's a very good chance you'll see that type of direction. Okay, B. Thoughts on how to multiply 4 plus 3i and negative 1 minus 2i?
4 times negative 1, 3i times negative 2.
FOIL. This is a binomial times a binomial. Think about if those i's were x's. What would you have to do? And you would have to, you can say FOIL, you can say distribute. I don't know which word works better for your brain, but FOIL or distribute. So FOIL first. 4 times negative 1 is negative 4. Then I'm going to do outside, or I'm going to distribute the 4 again. 4 times negative 2i.
Negative 6i.
4 times 2?
Negative 8i.
Negative 8i.
Minus 8i. Then I'm going to do my insides. 3i times negative 1. Minus 3i. Then distribute that 3i again. 3i times minus 2i.
Minus 6i squared.
Minus 6i squared. Okay. What pieces do you see here?
The i's.
Okay, the i's. I'm assuming you're saying that minus 8i and minus 3i, we go back to basic algebra terms, are like terms. So what do you know about minus 8i minus 3i? That's going to be minus 11i. Nope, just minus 11i, because it's 8i's plus 3i's are 11i's. We still have out front the minus 4, and then minus 6i squared. What am I going to say about every time you see an I squared? Make it a negative 1.
Or just note that the sign in front of it.
Okay. So, if it's negative 6i squared, negative 6 times negative 1 means this really becomes a plus 6. So I really have negative 4 minus the 11i. We already cleaned up those like terms. Plus 6.
2 minus 11i.
Yeah, the 2 minus 11i, you combine negative 1.
Okay. So always go that final step. Like terms. Reals with reals, imaginaries with imaginaries. So here, negative 4 plus 6 is 2. And I still have minus 11i. Your answers at most today will be 2 pieces. A real part and an imaginary part. If you have three pieces, like -4 minus 11i plus 6, that means there were some like terms there you could have put together. Or you have an I squared you forgot to get rid of. Okay, C. 7i times 3i. Don't overthink it.
24 I squared. Not 20.
21.
21 I swear.
Okay,
At least
so
my basic.
I was adding.
7 times 3. This is just one term times one term, right?
Yes, this should be simple.
So 7i times 3i, 21
24.
I
Square.
squared. Am I done?
No, it's negative
No.
21.
We know I squared is -1. So 21 times -1,
The negative.
-21.
And all of it would be like this.
24.
Maybe it's
Okay.
24.
So
So it's allowed to just be like that?
now, so -21. If Math Excel was being difficult and they said it has to be A plus BI form, then this would be -21 plus 0i. I really don't think that's going to have to happen because I don't have it written here in my notes. And usually I write that type of stuff down in my notes. So, you can go ahead and do part D right now, or you can start it tomorrow at the beginning of class. We still have to talk about how to divide numbers. We still have to talk about how to solve equations using square roots and the quadratic formula. So, I would encourage you to go ahead and get started on the homework tonight because we've been through a good portion of the lesson. But we haven't talked about solving equations yet, and we haven't talked about dividing, so when you see fractions. But you can do some of the other stuff, okay? So we'll finish notes tomorrow, and that will make homework due on
Wednesday.
Wednesday.